So I am doing additive manufacturing. We are 3D printing metal and then testing its mechanical properties. The metal we're using is Inconel. It's a nickel alloy. It's a high temperature, high strength alloy used in combustors, jet engines, and rocket nozzles. What we're trying to do is take the metal from being the traditionally manufactured metal where we're all used to seeing with the machining, and now we want to be able to 3D print it, which allows us to build these really complex geometries that are very expensive to manufacture with the machining process. But in order for us to be able to use those 3D printed parts, we have to understand what their quality is, how consistent the printing process is, and the actual mechanical properties of those 3D printed parts.
So here at AFIT, we're trying to drive additive manufacturing and become a cornerstone of quality assessment for the implementation of additive manufacturing technologies for broader use to the Air Force. So Major Newell stands out in that he's able to drive technical innovation and utilize all the capabilities that we have at AFIT, both in the classroom and also in our laboratories.
So for the warfighter, one of the things we could be doing with 3D printing is 3D printing spare parts. But right now, 3D printing is still such a new technology, we can't just, I could 3D print a metal part that looks and it would fit on an aircraft, but we have no confidence that once you actually bolt it in and fly that aircraft, that part would actually stay together. So the research we're doing is showing that these parts do survive, that they have the same properties of the traditionally formed parts. So for the warfighters, one of the great things would be increasing repair time or increasing supplies, especially for like older aircraft, like the A-10 is a good example where its supply chain it's so old that it's really hard to find a lot of parts for it. But if we could 3D print parts for it and fly those, that'd be great for the Air Force.